So in this particular video, we are going to solve a numerical on equilibrium of coplanar non-concurrent force system. So up till now we have solved numericals on equilibrium of coplanar concurrent force system. This will be the first numerical that will be going through equilibrium of coplanar non-concurrent force system. So if you check out the statement goes like this: determine the support reactions for the beam shown. So the non-concurrent body that is being given is a beam AB, which is being supported at end A and end B by two supports. At end A we have a roller support, at end B we have a hinge support. Now we already have studied what are these supports, how they are symbolized, and what are their different notifications and what are the different reactions coming out of that. So already in the previous videos we have learned about this. So directly we are going to go with the solution. So now in this particular video our aim is to find out the reactions coming out of this supports. Now for that what we are going to do is we are going to go for its FBD. So whenever you are solving this kind of numericals, that is to find out support reactions, your first step should be to go for the free body diagram of the given mechanism. So we'll just check out how to go with the free body diagram. So already we have gone through this, how to draw the free body diagram, but still we'll go through it again. So free body diagram means what we have to do is that we have to make the given object or body free from all the supports and connections. So here we don't have any connections, but we have two supports, a roller support and hinge support. So we are going to make it free from it, but we don't have to make it free, but we have to replace it by the corresponding reactions coming out of that particular supports. And the other forces we have to represent them as it is. So what I will be doing is I will be again drawing this beam maybe. So I will be drawing it here. So this is A point, this is B point. I will urge all the students that follow the same procedure while going through the solution in your exams. You have to draw the given mechanism and extend the projections of all the points given below. So it will give a clear idea about where are the supports and what are the dimensions and where to represent what. So here we have A, here we have B, here we have C point, and here we have D point. Now first of all we will replace this roller support. So we all are familiar that a roller support is to be replaced by a single reaction. So here the roller support is resting horizontally, so the reaction will be perpendicular to it. So this will be the direction of the what you can say reaction coming out of the roller support. For example, we have a roller support likewise, and if this is the orientation, then in that case this will be the reaction coming out of that. So here the roller support is resting vertically, so the support reaction will be horizontal. So now this is the right orientation, and now it is acting at A point, and as it is acting vertically, we will call it as R, reaction at A in Y direction. Even you can call it as RA because there is no X direction reaction at this particular point. Now we have this 600 Newton force which is acting inclined at C point. So inclined forces, while you are drawing FBD, have this habit of resolving them into two directions. So this particular force will have these two resolving directions. As it is a force moving in fourth quadrant, this will be the resolving direction. This will be 600 cos of 45. This will be 600 sine of 45. So next we have a force at D point. So it is acting along fourth quadrant. So negative y-axis. So here its value is 100 Newton. Then we have a hinge support at this particular point. So a hinge support is to be replaced by one vertical reaction. We call it as RBY, and a horizontal reaction. So I will call this as B point here, and this as RBX. So a hinge support is to be replaced by two reactions, one in vertical direction, one in horizontal direction. Now here I have shown the horizontal direction to be moving towards negative x-axis. You can show it moving towards positive x-axis. These are assumptions that the directions are assumed. But if after solving you are getting RBX as a positive value, it tells us that the assumed direction is correct. RBX is moving towards negative x-axis. But if you are getting the value of RBX negative for this assumed direction, then it gives us that the RBX direction should be reversed, means the assumed direction should be reversed. So in that case, RBX will be moving towards positive x-axis. Now along with this particular support, we also have a vertically downward force at B point. So we have to represent it as it is. So 200 Newton force. So now this is how our FBD is ready. We will not show these dimensions because already we have taken the projections. So this is nothing but FBD of beam AB. So now once the FBD is ready, what we have to do is we have to go for the conditions of equilibrium. Now we already have gone through this, that for equilibrium of non-concurrent force system we have three conditions of equilibrium. So we have summation of Fx equal to 0, then we have summation of Fy equal to 0, and then we have moment about any point equal to 0. So we have to use these three conditions of equilibrium to get our required determinations, that is the support reactions. So here how many unknowns we have? We have RAY, RBY and RBX to be determined. So we will go with the first summation of Fx equal to 0. So if you observe this particular mechanism, now just observe the FBD of beam AB. In beam AB, check out the forces in x direction. So you have this 600 cos of 45 moving towards positive x-axis. So 600 cos of 45. Then we have RBX moving towards negative x direction. So minus RBX, and this is nothing but summation of Fx, and that you have equated with 0. So in this particular equation, the only unknown is RBX. Already it has been solved. So RBX from this you should be getting equal to 424.26 Newton, close to this. Now what we'll do is that we have gone with one equation. Now we'll go with the next. Summation of Fy equal to 0. We'll go for summation of Fy equal to 0. Now, in this mechanism, check out the forces acting in y direction. So here we have RAY moving towards positive y direction. So plus RAY. Then we have this 600 sin of 45 moving towards negative y direction. So minus 600 sine of 45. Then we have this 100 Newton force acting downward, so minus 100, and then we have this 200 moving towards negative axis, so minus 200. With that we have this RBY moving towards positive y, so plus RBY. Now this whole thing is giving you summation of Fy, so that you have to equate with 0. So now in this equation we have two unknowns, RAY and RBY. So we can't solve this, so we'll call it as first equation. Then we'll go with next, that is moment about any point equal to 0, summation of moment about any point equal to 0. So now here there is a choice for you all to go with a particular point. Now while selecting the point, you have to take care that try to select a point such that it will reduce your calculations. So if I am selecting A, what's happening that this moment created by this RAY will be 0, means this RAY will not come into this equation. So what will be having in the equation will be RBY. So you can get RBY, put it back, you will be getting RAY. Simultaneously, if you take moment about B, then the equation will not give RBY, you will get RAY in the equation. You will find RAY from that equation, put it here, and you will be getting RBY. But if you are taking movement somewhere other, then in that equation again we will be having two unknowns, RAY and RBY, and in that case we have to use the other methods, that is solving simultaneously and all that. So likewise you have to select a correct point. So now the two good options are either select A point or B point. So we will go with A point, summation of movement about A point, and we assume anti-clockwise as positive. Now our aim is to find out summation of movement about A. So now the forces which are passing through A, the forces whose line of action are passing through A, they will create zero movement about A. So this RAY, its line of action is passing through A, it will create zero movement about A. The 6 cos of 45, its line of action is passing through A, its effect rotational effect around A will be 0. Similarly, RBX, it's a line of action. It's passing through A point. So the movement created by this around A also will be 0. So now this 600 sin of 40 will create a movement about A. So it is creating a clockwise effect around A. So we have assumed anti-clockwise positive, so clockwise will be minus. Force is 600 sine of 45. The distance, perpendicular distance is 2 meters. Then we have this 100 Newton force, which is again creating a clockwise effect around A. So minus 100 into its perpendicular distance about A is 3 plus 2, 5. Then we have this 200 Newton force about A, it is again creating a clockwise effect, so minus 200 into its perpendicular distance about A is 2 plus 3, 5, 5 plus 2, 7. Then we have this RBY about A. Now it is creating an anti-clockwise effect, but its perpendicular distance about A will be same as that of 200 Newton, that is 7 meters. So we are going to be writing down plus RBY into 7, and this whole thing is nothing but summation of moment about A. And now this is what you have to equate with 0. Now in this particular equation, the only unknown is RBY. So you can get RBY from this, and you should be getting it equal to 392, somewhere close to 392.65 Newton. So once you have got this RBY, now you can put it in first equation. Already we have discussed this. Put it here. Once you have got this RBY, the only unknown in this equation is now RAY. So by backward substitution, you should be getting RAY as again it is solved 331.6 Newton. So this is how we have found all the required determinations, that is the support reactions, RBY, then RBX, and then RAY. So I hope that you all have understood this particular numerical, how to find out the support reactions for non-concurrent force system which is in equilibrium. Thanks for watching the video.